Alright, so today we're going to talk about significant figures, and a lot of you guys had trouble with this on the pretest, so this is definitely something you want to pay attention to. Alright, so the first thing, the way that your book describes doing this, and I think it's actually a really good method, is to write each number in scientific notation. So 3.07 times 10 to the 0 grams or whatever. And then, without losing any of the digits of the significance digits from the measurement, and that way you can see which zeros are placeholders or not significant placeholders for order of magnitude type of things, or whether they are actually significant zeros. So here it's pretty easy to see that all of these, this is just like a measurement from an analytical balance, so all of these would be significant, so we out to 4 digits. Here, when we write it in scientific notation, same thing, 4 digits is a significant figure. Or 4 significant figures. Here, however, you have 0.7 milliliters, and so when you write it in scientific notations, then you see that actually only the 7 is significant. Same thing with 6.022 times 10 to the 23rd. We have 4 significant figures there. 50 milliliters is a question mark because it's not really clear whether that 0 is significant or not. Usually you see a decimal point after the 0 if the 0 is supposed to be significant, so it's more likely that it's actually 5 times 10 to the 1. Alright, so now that we understand significant figures, we need to understand how to do significant figures within the context of doing mathematical calculations. So if you're going to do addition or subtraction, the way you do it is that the results have the same number of decimal places as the contributing number with the fewest decimal places. So here you have something with 4 decimal places being added to something with 2 decimal places, like an analytical balance measurement and a volume and a top loader balance. And so what you have are, because the 107 actually has 2 decimal points, then you have 2 decimal points in the answer. So this 37 is not significant. When you're doing multiplication or division, it's pretty much the same. It's different. So the results in this case, the results have the same number of significant figures as the lowest contributing number. And so here you have the lowest number of significant figures is the 3.72, so actually 3 significant figures, so your answer only actually has 3 significant figures. Alright, and what's written up here is that you don't include constants, so if you have to multiply by 2 as a constant or multiply by Planck's constant, you don't actually count those towards significant figures. Alright, so the way that your book says to do it and the way that I do it is you want to determine this, you want to round and then determine the significant figures at the end of the calculation. So I usually keep an extra digit when I'm doing a calculation, and then at the end I round off and do my significant figures. Alright, so one more mathematical operation is log x, or 10 to the x. So here you have 6.142, or 10 to the 6.142. And so here we have the 6 is actually sort of a placeholder it's an order. It ends up being an order of magnitude. So then actually it's only the numbers after the decimal place. So 10 to the whatever, and it's only the numbers after the decimal place that are significant figures. So then your answer here, 3 significant figures, your answer is going to have 3 significant figures. Same thing, same idea when you're doing a log. So you have 5 significant figures, so you're going to have 5 digits after the decimal place that are significant when you actually do that log function. And that's all. So hopefully this is helpful to you guys.